Hi, my name is Dr. English, and today we're going to be talking about average atomic mass. Specifically, we're going to be looking at a little bit of an isotope review, asking ourselves what is average atomic mass, how to calculate average atomic mass, and I'm going to show you two different methods of how to do this, look at some average atomic mass examples, and then finally do a little bit of practice. What is an isotope? Isotopes are atoms of the same element with varying numbers of neutrons. So they're going to have the same atomic number, but different atomic masses. So in other words, the protons are going to be the same in all the atoms, but the number of neutrons will be different. Isotopes are indicated by their mass number, which is either written after the name, that's one way that we can see it, or to the upper left of the element symbol. So in this case, the two examples I have here are of carbon. Carbon written out as just a word, carbon 12, or carbon superscripted as we see right here. So we're going to look at three different isotopes of carbon, carbon 12, carbon 13, and carbon 14. And here they're represented basically as nuclei. So in this nucleus right here, we have 6 protons and 6 neutrons. In this nucleus right here, we have 6 protons and 7 neutrons. And in this nucleus right here, we have 6 protons and 8 neutrons. So in each case down here, the number of protons are the same, but the neutrons are different, which gives us these different mass numbers that you see right down here. Now the whole purpose of this tutorial is actually to start talking about these percentages right here and what they mean when we talk about the concept of average atomic mass. So what is average atomic mass? Here's our little diagram that we had in the previous slide, and we're going to focus on the fact that this carbon exists not as just one mass, but actually of 3 different isotopes, and each isotope has a certain mass that's associated with it. So when we find average atomic mass, it's going to be associated with those 3 masses and the percentages of each of those isotopes that exist. So mass numbers of elements on the periodic table have decimals, which is really important to notice because they are weighted averages of all the various isotopes of that element that exist. The key thing here is that you can't just say, oh, carbon 12, I really like you. So you know what? All carbon is going to have a mass of 12 and just sort of disregard the rest. No, carbon 13, carbon 14, we really don't need to acknowledge you at all. That's not reasonable because we do have carbon 13 that exists and we do have carbon 14 that exist, even though, as we see up here, relatively small percentages, but they still need to be factored in terms of figuring out the overall representation of the mass of carbon that appears on your periodic table, which is why it's a weighted average. So to summarize, you can't just focus on one isotope and disregard the others. How to calculate average atomic mass, method 1. The first method that we're going to look at is determined by adding together the percentage of each isotope, multiplying it then by its mass number, and dividing the sum by 100. So let's look at an example. The element iridium is composed of 38% iridium-191 and 62% iridium-193. The atomic mass of iridium is, so the way that we would set this up is that I would take my percentage, the first percentage listed, which is 38, and I'd multiply it by its mass number, so 191. And then I'm going to add that to the second percentage, which is 62, and multiply that by its associated mass number, which is 193. And then I'm going to divide the whole thing by 100. So I haven't done anything fancy to the numbers up here. I've just basically taken the percentage times the mass plus the percentage times the mass divided by 100. So if I do 38 times 191, I get 7,258. And I'm going to add that to 11,966. And I'm going to put odd all over 100. So if I add these together and I divide by 100, I'm going to get 192.24 U. We're looking at how this is working out. This number right here is these two numbers multiplied together. And this number right here came by multiplying these two numbers together. So just in case you're like, where did you get the 7,258? It's because I multiplied these two numbers together, and now I'm going to take these two individual isotopes basically and add them together, divide by 100, and get my average atomic mass. Now this is one method of doing this. Let's look at the second method, and actually this is the method that I prefer to use in my classroom. I'm going to convert each percentage to a decimal. So the percentages that are listed, I'm converting them into a decimal. Then I'm going to multiply the decimal by its associated mass that's listed. Then finally, I'm going to add the isotopes together to get the average atomic mass. So we're going to use the exact same example again, but going with this particular method. So one more time, the element iridium is composed of 38% iridium-191 and 62% iridium-193. The atomic mass of iridium is, so I'm going to take that first percentage, which is 38%, and I'm going to convert it into a decimal. 0.38, and then I'm going to multiply it by its mass, 191, plus the 62% I'm going to convert into 0.62, and I'm going to multiply it by its mass, 193, and if I work that out, if I do the decimal times the mass for the first one, I should get 72.58. Then if I take the next one, 0.62, and multiply it by 193, I should get 119.66. So I'm going to do that. So 0.38 times 191 gives me this number, and 0.62 times 193 gives me this number. So now all I'm going to do is add these two together, and I should get the exact same answer that I did for method 1. That being 192.24. And that's how you use the second method. Now it's your turn to practice. So what I want you to do is stop, do the two examples on your own, and then check your work with me. Welcome back. Let's see how you did. So let's look at the first question here. Chlorine-35 has a natural abundance of 75.5%, while chlorine-37 has a natural abundance of 24.5%. What is the atomic mass of chlorine? So again, I'm going to say, all right, this is my first mass. I'm going to go to my percentage first and convert that into a decimal. So that is going to be 0.755, there we go, times its mass, which is 35, plus, okay, chlorine-37, I'm going to list my percentage first, so I'm going to convert that into a decimal. So that's going to be 0.245 times its mass, which is 37. So if I multiply together 0.755 times 35, I should get 26.425. And I'm going to add that to 0.245 multiplied by 37. And when I do that, I should get 9.065. So when I add these two numbers together, my final answer should be 35.49 U. And you know what? If you're doing this and you know that this is going to be the average atomic mass, which is listed on your periodic tables, you probably should check your periodic table and make sure that your mass is relatively close. Let's look at the next one. Silicon has 3 isotopes. Silicon-28 is 92.23%, Silicon-29 is 4.68%, and Silicon-30, don't get distracted by that, the 30 is still a mass number, it's just being represented a different way, is 3.09%. What is the average atomic mass of silicon? Alright, so I'm going to set this up again. So silicon-28 is 92.23%. So I'm going to take that 92.23% and convert it into a decimal. 0.9223, and I'm going to multiply it by 28 plus, what's my next one? Silicon 29 is 4.68%. Now be careful here. You're converting these into decimals. So you basically have to move over 2 decimal places. So when I do 4% and I convert it over, it's going to be 0.0468 as my decimal. I'm going to multiply that times 29 plus, and then my next percentage, same thing here, 3.09. I've got to move it over 2 decimal places. So 0.0309 times 30. So now I need to do the work to figure this all out. So I'm going to start out by multiplying 0.9223 times 28, and I should get for my answer 25.8244. And then I do 0.0468 times 29, and for that answer I should get 1.3572, and then finally 0.0309 times 30, and I should get 0.927. So if I add all of these up, I should get a final answer of 28.1 U if I've done my math right. And again, the best thing always to do is, if you know that you're dealing with this type of situation, go to your periodic table, check the average atomic mass that's listed on there. Your answer should be relatively close. So what did we learn in this little tutorial? Well, we went over a little review of isotopes. We talked about what is average atomic mass. I showed you 2 different methods to calculate average atomic mass. We did some average atomic mass examples, and then finally at the end we did a little bit of practice. Need more help? Feel free to contact me. Have a great day.